This video is the test review for Module 2, Linear Equations, Inequalities, and Systems. Question 1. Match the system of inequalities to its graph. Now for this one, I would just look at the symbols that you have listed here. Now in this first one, they're both greater than. Now you'll notice that the lines are all identical. It's just the shading is different. Now, if it's greater than for both of them, that means it has to be above both lines. And the only one that has the shading above both lines is letter C. The second one, this one is less than and this one's greater than. So if it's greater than one line but less than the other one, it has to be shaded in between the two lines. So that would be graph A. And the third one, they're both less than. That means they have to be underneath both lines. And the only one that's underneath both of them is letter B. Question 2. Solve the system of inequalities here. So we're going to graph them, and then we're going to shade where the solutions are. So for these, treat these like linear equations. So treat this first one as y equals 3 minus x, or y equals negative x plus 3. So the y-intercept is at 3, and it's going down by 1. So I'm just going to put my dots in here so you can see where our line is. And because it has the equal to part, I know this is going to be a solid line. So I'm going to draw a solid line for my graph here. The next one I'm going to do in green is treat this one like y equals 3. So it crosses the y-axis at 3. It's a horizontal line. It's got the equal to sign underneath it. So this would be a solid line, solid horizontal line. And then the third one I'm going to use in red. It's got to treat that one like y is equal to negative 5. So it crosses the y-axis at negative 5. So I'm going to put a point here. And then I'm going to go straight across a horizontal line. Now all we have to do is determine where to shade. So it says that it's got to be less than the blue line. So less than the blue line means down here, here, or down here. It has to be greater than the green line, so above the green line and below the blue. So that would be in that section here. And then it has to be above the red, above the green, and below the blue, which would be right here. So this upper corner would be our solution. Question 3. Solve the system of equations. So we have 3 equations, 3 variables. We need to find all of them, and we're going to use elimination. So if I look at my equations and my variables, I think I'm going to try to eliminate the x's. Now it doesn't matter which variable you use to eliminate. I'm just going to choose the x's. So if I look at 2 and 1, the least common multiple of 2 and 1 is 2. So if this top one's a positive 2, I want this bottom one to be a negative 2. So I'm going to have to multiply that by a negative 2. So the first one, I'm going to rewrite the first one, which is 2x plus 3y minus z equals 0. And the next one, if I distribute a negative 2, that gives me a negative 2x plus 4y plus 8z equals negative 2 times 14 is negative 28. Then I combine like terms. The x's eliminate each other, and I'm left with 7y negative 1z plus 8z is a positive 7z equals negative 28. Then the next part, I'm going to take the top equation and the bottom equation. I have a 2x and a 3x. So I need one of them. The least common multiple of 2 and 3 is 6. So I'm going to multiply this top one by 3, and that's going to give me 6x plus 9y minus 3z equals 0. And this bottom one, I need a negative 6, so I'm going to multiply this by a negative 2. Negative 2 times 3x is negative 6x. Negative 2 times y is negative 2y. And negative 2 times negative 8z is a positive 16z. And that's going to equal negative 2 times 17 is a negative 34. And when I combine like terms, the x's eliminate. I have 9y minus, or not 9y, 9y minus 2y is 7y. Negative 3z plus 16 is a positive 13z equals a negative 34. Now if I write this one underneath the black one I have here, so I have 7y plus 13z equals a negative 34. I can see that my y's are the same, so I just have to distribute a negative 1. So I'm going to distribute a negative 1 on the top one. So that's going to give me a negative 7y minus 7z equals a positive 28. And when I simplify that, the z's cancel out. 13z minus 7z is 6z equals negative 34 plus 28 is a negative 6. To get z by itself, I'm going to divide by 6. And I'm left with z is equal to negative 1. So if z is negative 1, I'm going to substitute that into one of these two equations here. I'm going to use this top one. So I have 7y plus 7 times negative 1 has to equal negative 28. 7 times negative 1 is negative 7, so I'm going to add 7 to both sides. And now I'm left with 7y equals a negative 21. And to get y by itself, I'm going to divide by 7. And I'm going to have y is going to equal a negative 3. Now all I have to do is find my x. And I have to go back to the original equations. And I'm going to choose this top one here. And so I'm going to have 2 times x plus 3 times negative 3 minus a negative 1. And that has to equal 0. So that's 2x. 3 times negative 3 is negative 9. Negative 9 plus 1 is negative 8. That's going to equal 0. Add 8 to both sides. And now I have 8 is equal to 2x. Divide by 2. X is going to equal a positive 4. Now you could have used your graphing calculator and used matrices to solve that, but this is how you would solve it using elimination. Question 4. If 8x minus 3y equals negative 1 and x equaling negative 12 minus 2y, what are the values of x and y? So this one I would use substitution because they told us that x equals negative 12 minus 2y. So I'm going to substitute this in for x in this other equation. So that gives us 8 times negative 12 minus 2y minus 3y equals negative 1. So now I'm going to distribute an 8. That gives us a negative 96 minus 16y minus 3y equals negative 1. I need to get this 96 to the other side, so I'm going to add 96. And when I do that and combine like terms on the left, I'm left with negative 19y equals 95. To get y by itself, I'm going to divide by negative 19. And 95 divided by negative 19 would give us negative 5. So y is going to be a negative 5. To find x, I'm going to substitute negative 5 and I'm going to put it into this one right here. Now, I could put it in the other one if I wanted to, but here I already have x by itself. So negative 12 minus 2 times negative 5 really means negative 12 plus 10, which will give us a negative 2. So our solutions would be x is negative 2, y is negative 5. Question 5. A high school band was selling ride tickets for the school fair. On the first day, 250 children's tickets and 150 adult tickets were sold for a total of $550. On the second day, 180 children's tickets and 120 adult tickets were sold for a total of $420. What was the cost of each ticket? So we're going to write a system of equations here. I'm going to use C for children's tickets and A for adult tickets. So on the first day, they had 250 children's tickets plus 150 adult tickets, and that gave us a total of $550. And the second equation is going to be the second day, which they had 180 children's tickets plus 120 adult tickets, and that's going to give us a total of $420. Now we have to determine which variable we're going to solve for first. Now I'm going to eliminate the A, the adult tickets. So if you think of the least common multiple of 150 and 120, that would give us 600. Now, one way to figure that out is all of these are multiples of 10. So if you divide every single number in both equations by 10, you have 15 and 12. Now, 15 and 12, you can find out what the least common multiple of 15 and 12 would, which would be 60. And then if you multiply 60 times 10, that would give you your 600. The other way would be just to multiply both numbers, like 150 times 120, but that's going to give you a really large number. So you could easily do a guess and check for that one, but I know right now that the least common multiple of 150 and 120 is 600. So the top one, I'm going to multiply. So to get 150 times, I believe, 4. So that's going to give us 600. So I'm going to multiply the top one by 4. So 4 times 250C is going to give us 1,000 C. And then I have plus 4 times 150 is 600 A. And that's going to equal 550 times 4. That's going to give us 2,200. And then the next one, the next equation, I need this to be a negative 600. So 120, so I got to figure out what do I multiply 120 by to get 600. That would be 5. So I'm going to multiply the second one by a negative 5 so I can get a negative 600. So we have 180 times a negative 5 gives you a negative 900. So this is going to be a negative 900C. And then minus 600A equals negative 5 times 4,200, or not 4,200, 420 will give you a negative 2,100. Now I combine like terms, that gives me 100C equaling 100. To get C by itself, I'm going to divide by 100. That means each child's ticket is $1. Now, if I put 1 in for C in one of the two equations, I can now solve for A. So I'm going to put it in the top one. So we have 250 times 1 plus 150A equals 550. So I'm going to subtract the 250 on both sides, and that leaves us with 150A equals 300. Now if I divide this by 150, the adult tickets would cost $2. Question 6. Here we have this going to solve and graph linear, just inequalities here. So now this first one, when the absolute value is by itself, it can never equal a negative number. So for this one, it's saying it's less than or equal to a negative number. That can never happen, so this would be a no solution. Now the second one here, the absolute value of x is going to be greater than x minus 1. Now whatever comes out of the absolute value, it's going to be a positive number. And for here, I'm going to have whatever x is minus 1, it's going to be smaller than whatever x is. So for this one's always going to be all real numbers. But one way to check this out is if I were to take this out of the absolute value, x is greater than x minus 1. Now if I were to subtract x on both sides, I now have 0 is greater than negative 1. Well, 0 will always be greater than negative 1. So this one would be all real numbers, or many solutions. Now to graph it, it would just be on a number line, and say I just put 0. It would just be everything on the number line. And our last one here. Here I have the absolute value by itself, so I can do case 1 and case 2. So case 1 would be 3x minus 1 is less than 5. And let me rewrite this one, because since this is less than, I use the keyword and, or I can make it a simplified form. So I'm going to put 3x minus 1 is less than 5, but it has to be greater than a negative 5. So that's my case 1 and case 2. So to simplify this, I'm going to add 1 to all the sides. And now I have 3x is less than 6, but greater than negative 4. And then divide everything by 3. I'm now going to have x is less than 2, but greater than 4/3. And now on a number line, I'll say this is 0, this is 1, this is 2, this is 3. I'm going to have an open circle at 2, because it cannot equal 2, and an open circle at 4/3, which is 1 1/3, so that's going to be roughly negative 1 1/3. So I got to fix this. So my number line would be here. So I have 3, 2, 1, 0, negative 1, and then this would be negative 2. Now negative 1 1/3 will be roughly here. Open circle at 2. And I know I'm going to have, it's going to be everything in between. So that would be our graph for this inequality. Question 7. Here we're going to solve this absolute value equation. So to do this, we need the absolute value by itself. So I'm going to subtract 5 on both sides. And I got negative 3 times the absolute value of 2 plus 2w equals a negative 12. To get the absolute value by itself, I'm going to divide by negative 3. And now I have the absolute value of 2 plus 2w is equal to a positive 4. So it can equal a positive number, so I'm going to do case 1 and then case 2. Case 1 is 2 plus 2w equals a positive 4. And case 2 is going to be 2 plus 2w equals a negative 4. And then simplify this, so I'm going to subtract 2 on both sides. And I get 2w equals 2. Divide everything by 2. W is going to equal a positive 1. This one we're doing the same thing, subtract 2, and I get 2w equals a negative 6. Divide by 2, w is going to equal a negative 3. So my answers are 1 and negative 3. Now you can put into the original equation to verify it. So if I put 1 in for w, 2 times 1 is 2, 2 plus 2 is 4, absolute value of 4 is 4, 4 times negative 3 is negative 12, 5 minus 12 is negative 7, which that's what it equals here. If I put negative 3 in, 2 times negative 3 is negative 6, 2 plus negative 6 is negative 4, absolute value of negative 4 is 4, 4 times negative 3 is negative 12, 5 minus 12 is negative 7. Question 8. Write an equation for the nth term of an arithmetic sequence and then find the 11th term. Now you can use the formula a subscript n equals a subscript 1 plus n minus 1 times the common difference. To find the common difference, I'm going to look at the pattern. Negative 5 to negative 3 to negative 1 to 1. I'm adding 2 every time. So to find the 12th term, so I'm going to do a subscript 12. And we have to do write an equation for this first. So to do that, I'll do a subscript n equals the first term of negative 5 plus n minus 1 times the common difference of 2. So if I distribute the 2, I have a subscript n equals a negative 5 plus 2n minus 2, which will give us an equation of a subscript n equals 2n minus 7. Now if I put 12 in for n, because I'm trying to find the 12th term, I would have a subscript 12 equals 2 times 12 minus 7. So that's 24 minus 7. So the 12th term, 24 minus 7, would give you 17. Question 9. Write an equation for the nth term of the arithmetic sequence and then find the 12th term. So here they're giving us the 5th term, and the 5th term is negative 3, and then the common difference is 8. This one I'm going to do a little bit differently because this 5 here is our x and this is our y. So if I put it in slope-intercept form, which is y equals mx plus b, this is going to be our m. So my y is negative 3. When my slope is 8, my x is 5, I need to find the b. So I'm going to subtract 40, because that's 8 times 5 is 40, on both sides. And b is going to equal a negative 43. So my equation would be y equals 8x plus or minus 43. Now if I use the same formula that I had over here, that's the same thing as saying a subscript n equals 8n minus 43. So now to put 12 in for n, I would have a subscript 12 equals 8 times 12 minus 43. So this would be 96 minus 43. that means a subscript 12 would give us 53. Question 10. Write the equation in standard form and identify your a, b, and c. Now for this one, standard form is in ax plus by equals c format. You cannot have fractions involved, and your a has to be positive. So your x term has to be positive. So when I have fractions, I'm going to multiply by the least common multiple. The least common multiple of 3 and 2 is 6. So I'm going to multiply every number by 6. And that gives me 6y equals 6 times 2 is 12, divided by 3 is 4x, and then half of 6 is 3. Okay, I need my x and y on the same side with my x positive. So it's already positive here. So I'm going to subtract 6y on both sides. And then I'm going to subtract 3 on both sides. So my equation is going to be, now I'm just going to put my x and y term first. So I have 4x minus 6y, and this is going to equal a negative 3. So your a is going to be 4, your b is going to be a negative 6, and your c is going to be a negative 3. Question 11. Write an equation in point-slope form. Point-slope form is y minus y1 equals m times x minus x1. That satisfies the set of conditions. So we have to first find the slope of these 2 points. So this is x1, y1, x2, y2. We're going to use the formula y2 minus y1 divided by x2 minus x1. So y2 minus y1 divided by x2 minus x1. So we would have negative 2 minus a negative 8 divided by negative 3 minus 6, which this will give us 6 divided by negative 9, which will give us a negative 2/3. So if our slope is negative 2/3, I'm going to pick a point. It doesn't matter which point I choose. So I could do y minus a negative 8 equals the slope of negative 2/3 times x minus 6, which I give an equation of y plus 8 equals negative 2/3 times x minus 6. If you use the other point would be y plus 2 equals negative 2/3. So let me put that down. Y plus 2 equals negative 2/3 times x plus 3. Either one of these would be correct. And our last question, or not our second to last question, we have the feasible region of a linear programming problem has constraints of x is less than or equal to 1, y is greater than or equal to 0, and 4x minus y is less than or equal to 8. Find the location of the maximum and minimum values of f of xy equaling 3x minus 2y for this region by matching each value with its ordered pair. Now, we don't need to graph this. What we can do is we just have to plug these numbers in to this equation for x and y. Whatever one gives you the smallest value is the location of the minimum value. Whatever gives you the biggest number is our maximum. So for this one, I'm going to have 3 times 1 minus 2 times 0, which is going to give us 3. If I did 3 times 2 minus 2 times 0, that gives us 6. And this one would be 3 times 1 minus 2 times 4, which will give us 3 minus 8 is a negative 5. So the location of the minimum value would be C, 1, 4, because that gives us a -5. And the location of the maximum value, the biggest number, would be 2, 0, because that gave us 6. And our last two questions, twice a number minus a second number is -1. Twice the second number added to 3 times the first number is 9. Find the greater of the two numbers. So I'm going to label the first number as x and the second one is y. So it says 2 times x minus y is equal to -1. And it says twice the second number, so that's 2 times y is added to 3 times the first number. And that's going to equal 9. Now I would use elimination here. So I'm going to eliminate my y. So I'm going to multiply this top one by 2 because I already have a positive 2y. This will make it a -2y. So this is 4x minus 2y equals a -2. And that leaves us with 7x equaling 7. Divide by 7 on both sides. X is going to equal 1. So if 1 is one of our numbers, I can substitute 1 in for x. I'm going to do this up here. 2 times 1 is 2. If I subtract 2 on both sides, I get -3. And then I divide by -1. Y is going to be a +3. Now I can verify this. If I did 2 times 1 is 2, minus 3 is -1. So my two numbers are 1 and 3. On the last one, I'm going to use elimination here to solve this one. Since they're both the same signs, I'm going to multiply the top one by a -1 so I can eliminate my t's. So this will give me a positive 1r and a negative t equaling a -5. -2r minus 1 is -r equaling a -1. Divide by -1, r is going to equal a +1. So if I put that back into one of the equations, I have -1 plus t equals 5. I'm going to add 1 to both sides, and t is going to equal 6. So my solution is r is 1, t is 6. So that would be a good review for how to solve linear equations with inequalities and systems of equations.